Okay, this lesson is on multiple representations. So when we are working on a scenario, we're going to have a verbal description, we're going to have an equation, we're going to have a graph, and we're going to have a table. And it all deals with the same situation and what we're talking about. So we have to fill in what we're missing here. So they give us the verbal description in this particular one. Some that you're going to practice might give you the equation instead or part of the graph, and you just have to fill in the rest. So the verbal description says a baby giraffe measures 6 feet tall when it is born, and it grows an average of 1/2 foot each month. Well, just for purposes in a little bit, if we wanted to look at 1/2 as a decimal, we could also look at that as 0.5, which is the same thing. Okay, so 1/2 or 0.5. So we know when this giraffe is born, it's going to be 6 feet high, 6 feet tall. It's born that tall because giraffes are very tall. So it makes sense that they would be born 6 feet tall. And then every month they're going to grow 1/2 inch more every month. Okay, so let's maybe go, and it really doesn't matter. You could do any of these first, but maybe we'll just save the equation for right now. And I think probably for you guys, it might make it easier to go to the table. And so if we look at 0 months, that's when it was born. What is the height of the giraffe when it was born at 0 months?
6 feet.
6 feet. So we're going to put a 6 over here. Okay, and then after 1 month, it's still the 6 feet from when it was born, but it grows 1/2
So 6.5.
1/2 foot, yes.
Yeah.
So 6.5 feet. Yep, good. So that's where we get this. And so then in 2 months, it's going to go up another 1/2 foot, so it's going to be 7, and another 1/2, 7.5,
Is
8, 8.5, and
9.
9. There we go. Now, we are going to need to fill in the process here in a minute, but let's go ahead and go over to the graph. If this is our x and this is our y, we can plot these points because we have our 0, 6, that's an ordered pair, 1, 6.5, 2, 7, 3, 7.5, and so forth. So let's go over here and we're going to label our x-axis as our months. That's our months. And if this is 0 right here, we're going to go ahead and count by 1. So 1 month, 2 months, 3 months, 4, 5, 6, 7, 8, 9, and 10. And be careful that you're labeling. The numbers go on the lines right here. They are not in the middle of the squares. All right, and then the y value, that is our height. So we're going to write height for our y-axis. And then we're going to put feet. Okay, now if we look at how high up our feet go, it goes up to 9 feet. So we need to be able to get up to 9 feet, whatever we count by. So we need to count by something. I think we could count by 1s and get all the way up to 10, which would be plenty of room. And I know we've got some 0.5s, but that just means halfway would be, like this would be 1 and then 2, and between 1 and 2 could be the 1.5. Okay, so we're going to just label those on the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if you need to help you out, you can put your little halfway marks in the middle of there to represent the 0.5 spot. It'd be too much to write all of it, but if you wanted to, you could do that. Okay, and then we're going to go plot our points. So we start over here with our 0 months and 6 feet. So we're going to go to 0 months and then up to 6 feet, and we're going to put a point right there. Change that color to help us. So right here at 6 feet, we've got a dot. Okay, and then we go back to our table, and we can see that at 1 month, the giraffe is 6.5 feet. So we go back over to our table.
Between the 6 and 7.
Very good. We go over to 1 month, and then 6.5 is going to be right here between the 6 and the 7. Very good. Okay, and then keep following the table. 2 months would be at 7 feet. Good. 3 months would be at
in the middle of the 7 and 8.
Very good. And keep following that pattern. 4 months is at
8
feet. 5 months
8.5 between a 9 and 8.
And then 6 months is up at the
It's gonna be 9.
9. Very good. Now, we could keep going, but we're done with our data, and so we're just going to draw our little arrow here that shows the growth. Now, we really do, we could go up here to we should probably label that too, actually. We could call this the giraffe growth, maybe. Okay, all right, we do still need to fill in the process here, so in order to kind of see what's happening here, you know what, let's go ahead and do the equation. Since is this graph a proportional or non-proportional situation?
In proportion.
Non-proportional, because
Yeah.
it doesn't cross at the origin, right? So it's non-proportional, all right? Which means that we use the formula y equals mx plus b. Now remember, the m stands for the slope and the b stands for the y-intercept. So if we go to look for our slope, and you're allowed to pick any 2 points. Let's say I pick these 2 points right here. And I want to count up for my rise and then over for my run.
That'd be
I'm rising how much? From 7 to 8, I'm rising
1,
1. Whoops. And then how far am I running?
2.
2. So my slope would be 1/2.
1 over, yeah.
Very good. So we have y equals 1/2 x, and then the b is where the line is crossing the y-axis. So where is the line crossing the y-axis at?
6.
Right here at 6. Very good. So plus 6. So now that equation's done. So we've got our equation done, we've got our graph done. The only thing we're missing is this process right here, which if you look up here, you can see we do 1/2 or 0.5 if you rather, times the x, and then add 6. So if we come over here, we could say, okay, 0.5 times my x, which is my 0 months, plus 6. Well, 0.5 times 0 is 0, plus 6 is still 6. And then we do the 1. 0.5 times 1 would be 0.5, plus 6 is 6.5. And then 0.5 times 2 plus 6. Well, 0.5 times 2 is 1 whole. If you had 0.5 and 0.5, that makes 1 whole, plus the 6 gives us 7. So if we continue down, and most of the time, actually, you should be doing this before you actually get these values, because this is the process to get to these values right here. But I think with the situation, it kind of, I think you could kind of figure out what was going on with the height of the giraffe. Okay, so now that one is finished, but we have to answer some questions. So the first one says, explain how you found ordered pairs to create your graph. So how did we know where to plot these points? Where did we look?
The x and the y.
Good, the x and the y in the table. Very good. So the x and y values in the table. Good. Okay, what is the slope of the graph and what does it represent? Well, we looked right here and we found the slope to be
1/2.
1/2. Okay, so the slope is 1/2, which we know that slope is m now, right? So slope is 1/2. And then what does it represent?
The giraffe growth and growing.
The giraffe grows. We could say 1/2 feet or 0.5 feet each month. What is the y-intercept of the graph?
6, and it represents the giraffes when it was born.
Good, the 6, and that tells us the height of the giraffe at birth. Okay, What does the ordered pair 9, 10.5 represent in the context, talking about the giraffe and the growing? What does the 9 represent?
Months.
So 9 months, maybe we should write in 9 months, the giraffe will be what?
10.5 feet.
Will be 10.5 feet. Good. If the giraffe is 12 feet tall, now hold on, let's think about this. If the giraffe is 12 feet tall, how many months old it is? So if you go up here, you can look, here's the height. We didn't come all the way up to 12, but if you kind of look at what's happening, we stopped at 6 months, the giraffe was 9 feet tall, and if you continue to follow that pattern, or if you wanted to come over here and kind of extend, so we're looking for when it's 12 feet tall, right? Yeah, 12 feet tall. So at 7, it would be 9.5. At 8, it would be 10. At 9 months, it would be 10.5. 10 months, it would be 11. If you keep going, what would be the months for a 12-foot tall giraffe?
12 months.
12 months, good. All right, very good. All right, let's go to this page. All right, so looking at the next one here, we're talking about, we can see we have no verbal description. We've got an equation, we've got a graph here, and we've got part of a table. So this is Joey's Pizza Parlor, and they're talking about the number of toppings and the cost of the pizza. So if we look up here and we look at what's going on here, we've got 12, and then we got $1 or 1.5, which could be like $1.50 if we're talking about pizza toppings. So if we take this right here and we use it to, fill in the process here, we're going to take that 1.5x plus 12, and we're going to use that in the process right here. So 1.5x, meaning 1.5 times 0, because this is my x, remember, and this is my y, plus the 12. Well, 1.5 times 0 is 0, plus 12 would be 12. So the cost of the pizza with no toppings is $12. So that must mean just like a regular cheese pizza is $12 with no extra toppings on it. If we get one topping, 1.5 times 1, which means it's referring to money, $1.50 for one topping, plus the $12 pizza, that would be what?
13.5.
13.5, which is $13.50. Okay, let's do 2 toppings. $1.50 times 2 plus the 12 would be
15.
$15. And then continue on with your pattern. $1.50 times 3 plus 12 would be
16.5.
$16.50. Notice that every time we add a topping, we're going up by $1.50, which makes sense because the slope here is $1.50. All right, 4 toppings would cost how much?
18.
$18. 5 toppings,
$19.5.
$19.50, and then 6 toppings, $21. Okay, so I think we could, we can go over here to our graph and we can plot these because we know that, oh, I better hurry, the battery's gonna die. I know that we can plot the 0, 12, so if we go 0 and then straight up to 12 and put our dot, and then 1 topping is $13.50, so we go over to 1 and up to $13.50. Now, 13 is going to be right here between the 12 and the 14, so we have to go a little bit further, closer to the 14, so maybe right about there. And then 3 toppings is $16.50, so a little above the 16. Whoops, I put that in the wrong spot. What did I do? I forgot the 2 toppings. 2 toppings is $15 right there in the middle. 3 toppings is $16.50. 4 toppings is $18. 5 toppings is $19.50. And 6 doesn't really fit, does it? The last one doesn't really fit, but that's okay. And then we can draw our line through. Here we go. So if we wanted to write a verbal description here, we know that the pizza is $12 for a large pizza, because if we look at the graph, it says large over here, and that the toppings are $1.50. So we have to write a verbal description. So this, what is the pizza parlor called?
Joey's Pizza's Parlor.
Okay, so we can say Joey's Pizza Parlor. And by the way, when you write these verbal descriptions, they can be, it doesn't have to be exactly what I write, as long as you put the same information in it. Sells a large pizza for how much?
$12.
For $12. Each topping added costs how much?
$1.50.
Costs $1.50 each. Well, I don't need to put each again. Each topping added costs $1.50. All right, very good. So that one's done. Okay, let's see if we can get this next one done before the battery runs. All right, so this one is about watermelons. We got a watermelon patch here. We're talking about the number of watermelons and the weight of that number of watermelons. Now, they've already created the X and the Y for us. So we're going to go ahead and get those plotted quickly. So 5 watermelons weighs 6 pounds. So if we go over to 5 and up to 6, we can put our dot. 10 watermelons is 12 pounds. So over to 10 and up to 12. 15 watermelons is 18 pounds. 20 watermelons is 24 pounds. And 25 watermelons is 30 pounds. And then we could sketch our little line. Now, this particular one is actually going to be proportional because we could continue that pattern. It could have started here. 0 watermelons is going to weigh 0 pounds, right? That just makes sense. Okay, so
Yeah, it's close to going through the origin.
it is going through the origin, so it would be proportional. All right, now let's, we do still need to figure out that process, but I kind of like to look at the slope of my line, my rise and my run. So, and be very careful when you're looking at your increments here. It looks like it's rising too, but it's really not, because what are we counting by on the y-axis?
3s.
So we're rising 3 and then 3 more, which would be
6.
6. And then we're going to run. It looks like 1, but look down here on the
It's going by
x-axis.
5.
5's good. So
It's going to be 5.
so what's the slope there?
6 over 5.
Now remember, if it goes through the origin, that means we're using the y equals mx, not a plus b, because it goes through the origin. So that's the proportional relationship. So we would just write y equals, what was the slope?
6 over 5.
X. So that equation's done. All right. Then if we want to use that equation over here, because see, well, 6 over 5 is the same thing as 1.2. If we do 6 divided by 5, we get 1.2. So maybe we should write both of those. Y equals 1.2x. Because you might prefer to use the 1.2 times x when you're doing this part. So 1.2 times 5, if you type that in your calculator, if you do it manually, you'll see it gives you 6. And 1.2 times 10 is 12. And 1.2 times 15 is 18. 1.2 times 20 is 24. And 1.2 times 25 is 30. So all we have to do is fill in our verbal description. We've got a watermelon patch, and every 5 watermelons is 6 pounds. Or if we divide it, we can see that we get 1.2, which means that at Woodbury watermelon, is it patch?
Yeah.
Patch. Each watermelon weighs how much?
1.2.
1.2 pounds. Good. Now, as you work on these, you will see that there's a lot of different, you can pick which box you work in. You kind of have to, it's kind of like a puzzle. You work from one to the other. I do want to make a point though, real quick, that typically to get these y values, you want to go through this process, because this answer right here is coming from this work. It was just in this situation, these were already given to us, so we kind of went over to this direction first. Okay.